So hi, I'm Rebecca, and today I'm going to be talking about DNA replication. DNA is a double helix, so in order for it to occur, there are single-stranded binding proteins that prevent the hydrogen bonds from reconnecting. So this is the leading strand because it goes from 3 to 5. And this is the lagging strand because it goes from 5 to 3. So it always has to go from 5 to 3. So they're anti-parallel, and the replication that occurs would be 5 and 3, and this one would be 5 and 3. So now DNA polymerase 3 comes in, moving in the 5 to 3 direction, allowing the nucleotide bases to pair with the other bases. So now for the lagging strand, it has to set a primer because it doesn't know where to start, because it has to move from 5 to 3. And the primer pairs up with its nucleotides. For the lagging strand, it has to go from the 5 to 3 direction. So because the anti-parallel goes from 3 to 5, it doesn't know where to start. So a primase has to come in, and RNA is paired. Okay, so after the primase set the RNA, DNA polymerase then is able to come in. So DNA polymerase is then able to match the DNA nucleotide pairs. So primase continues to move up to set another primer, and DNA polymerase 3 is able to fill in those fragments with DNA nucleotide base pairs. DNA polymerase 1 then is able to replace RNA with DNA. However, there is space between these Okazaki fragments, and ligase then is able to come in because it creates, for it to occur, there can't be any RNA. But these sections where like this part started and then where another primase set its fragments, those are Okazaki fragments. So there's a space between them and they're not connected. So ligase has to come in and be able to phosphate bond, and it allows for it to remove the space and be a continuous strand.